you is, and if I can find the remote, is something from the Connected Chemistry curriculum, which is out of UIC. And last year they were looking for volunteers to do action research, which meant that you would use their classroom materials for 4 units throughout the year. It's a free download, and it's computational modeling, this idea that you take computer simulations and you have a model that you allow students to kind of work with. I put some quotes there from Carnegie Mellon about what computational modeling is, if you've never heard that before, but I, in my classroom, talk about thinking particles. I want the kids to think what the particles are doing, what the molecules are doing. And I'm always, for years, I was really stumped when I was explaining a homogeneous mixture and how that's different from a compound, for example. And so I came across this, and it's really kind of changed what I do in my classroom. And the little triangle thing that I passed out are the 3 things that I talk about, which is that we do labs, which are macroscopic, that's the hands-on. And then you write equations, which is the symbolic, like the representational. Did the handouts get stuck somewhere? Oh, they're here.
Oh, they're here.
They're here. Yeah. And then the third thing, which I never effectively incorporated before this, is the particulate, or the submicroscopic is really what it is. I start with submicroscopic. I connect with the fact that in biology, they were using cells, right? And we talk about, so what scale are we on? We're on a scale that we can't see. So all year long, I'm going to have my students imagining something that I can never, ever, ever show them, right? So what this does, and I'll just show it to you so you can see it, there's all these different simulations, and like classifying matter, you choose a particular simulation, and you start out really simply with something like this. It's based on actual approximations. It encourages, there's an actual curriculum that goes with it, so if you want to see any of the full units, it encourages students to actually draw the pictures. That's actually part of the curriculum. We got these books because we did the research, but you can download it all online. And so when you start talking about water molecules, again, already you're talking about, well, how do you know that that's a liquid, right? What phase is that in? Do you think that that's a liquid? And then there's all different kinds of simulations. So you can do, I think this is supposed to be silver, for example, and it doesn't do much. But what I like is that then you can get into things like mixtures. So you can start talking about the fact that what's happening, again, on a molecular level with a mixture, that these 2 things are kind of going back and forth, and they're not combining. Yeah?
Does this program work on the iPad? Or is it Java?
I believe it does not. It's Java-based, I think. But again, don't quote me on that, because we don't use like a lot of iPads here. I know it doesn't work on our, we have a Linux-based, so it doesn't work on that. Yeah.
Can you click display voices?
Yeah, oh yeah, sure. I don't think that works yet. So you can see the intermolecular forces. Now, where this actually came about, and the reason Amy Lefevre, who works with me here, stumbled upon this 2 years ago, because in equilibrium is where I struggled the most to have students understand how it was dynamic and the particles were moving, and I love their equilibrium unit. I think it's a great way to have students explain. They have units for almost everything. I think I've got equilibrium, chemical reactions, all that kind of stuff. What I will tell you, it is a full curriculum. Again, there's books, there's activities. I think it was written for a little lower level regular, right? So I would pick and choose what you're going to use if you're going to use the books and have students drawing and writing about it. And I combine a lot of the activities rather than having, it'll suggest to run 5 simulations. I might have the kids run 2 and then talk about it as a class and kind of add things on there. So I think the curriculum is a bit long-winded, as it were, but then it has a lot of discussions. It has kids give evidence. So they're telling me, if they're going to say gases are a fluid, they're going to tell me because I saw the particles slide past one another and they stay connected. And I found throughout the year I was saying, oh, when we write H2O, that's the same as this. Those represent the same thing. And I just can honestly say I don't think I ever did that before and made that clear. So yeah, so that's it. That's what I got in terms of. The last thing that's on there,